problems, but it ends up being a relatively poor abstraction. It's abstracting away the mechanics of making the HTTP request rather than embracing the bits about HTTP that actually make it useful. And even then, I didn't actually show it, but that abstraction was also leaking detail still. So it was a leaky abstraction because we still got the response back, which would be just the normal jQuery AJAX response with all of the HTTP response details in it. So this isn't a problem that's specific to jQuery by any means, and I don't mean to pick on jQuery. It's just it's one of the most popular libraries, so it's the easiest to demonstrate. Every library that has some AJAX functionality tends to have this fundamental issue. So really kind of what the solution here is to really kind of think about what the abstractions that we should be doing. And we should be working with resources. I mean, HTTP is fundamentally about getting and manipulating resources on a server rather than dealing with the low-level mechanics of actually how do we make a request. So there's a little library that I created called rest.js. It's a very thin wrapper around basically the raw request and response. I mentioned earlier it works with XHR as well as Node's HTTP libraries. Also have support for JSONP and even IE's cross-domain request. It runs in CommonJS and AMD, so whatever environment you want to work with, we're using modules. So if you're not familiar with modules, everyone in Node, it's just a straight up require REST. It's dead simple. If you're in a browser, typically we require an AMD loader. So if you're not familiar with that, you basically just define your module and you specify your requirements and they get injected in at runtime. So what does rest.js actually look like at runtime? Well, we have this REST function, and we can then again get that URL, and it returns a promise for the response. And if you think about what I just was talking about with jQuery, I mean, this is exactly the same pattern. So, I must obviously not be very good at what I do. So before I get really into deep about what makes REST REST, there's a concept out there of the Richardson maturity model. And this is basically, anytime someone starts talking about a maturity model, pay attention, figure out what they're talking about, figure out how much of it really is important to you, and then just figure out where you want to get off the train. But at the very low level, what they call level 0, it's basically just random requests going off all over the place that have really no semantic meaning, but somehow the client and server figure out what to do. Level 1 is where you actually start using resources. So instead of you can actually start to access things in a more resource-oriented fashion rather than trying to do RPC over HTTP or some other hack. Level 2 is actually using HTTP verbs, so using gets to load resources, put to create resources, put to modify resources or create more resources. And then finally, level 3 is using hypermedia APIs. So if you think about the web, you have a page of links, and when you navigate to that page, you get the links and you get the context of it, and then you figure out, okay, I want to follow that link, and then you get another page that has yet more links, and you keep following that. So the idea of hypermedia resources is that for your data APIs, you again have resources with collection of links, and you navigate those links to traverse the object graph, rather than having to figure out what the URL structure is in advance that server has to support, and then going through and parsing that out yourself. So back to what rest.js is. So it mentioned earlier, it's an abstraction to work with resources rather than just an abstraction to make requests. So of course, we give you full access to the request and response objects, all the properties that you can put onto a request or a response you have access to. But really the advantage is that we have this notion of an interceptor that allows you to really apply advanced behavior to that core request response facility, so that we're not baking in a bunch of knowledge into the actual lowest level client, but we're applying it on after the fact. And really what that allows you to do is configure your clients once and then share them with your application. So digging into what actually an interceptor is, I kind of just talked about that. So let's actually show one. So in this case, we basically start with the REST client, and then we're going to chain off of that the basic auth interceptor. And to that interceptor, we give it a little bit of configuration. So we can give it a username and a password. then basically we would get back a resulting client. And that client, again, is just another function where you can pass the same request structure to. And basically what happens under the hood is that before making that request, it'll actually apply that username and password and actually authenticate it for you, so that the response is the authenticated resource instead of just an anonymous resource. So what can interceptors do? Really just about anything. So they fundamentally hook and intercept into the request or response lifecycle so that they can either augment a request response or replace it entirely. They can follow the natural chain of interceptors, or they can replace it and send them somewhere off and send them where completely different. They can also detect and recover from errors. Promises has the notion of a successful resolution versus an error state. So it can push that promise into one or the other states. And of course, it can also abort the request if you don't want to wait for it anymore. So the only thing interceptors really can't do is alter another configured client, because a client is just a function. Functions have closure. You can't manipulate it once it's created. So that's actually also what makes it safe to take a client that's once configured and share it within your application. So out of the box, we have several different interceptors. Some of them are just low-level basic things, like being able to default different portions of the request. Like if you always want to add certain headers to your request, you can do that. Or if you only really care about the response entity instead of the response headers and other meta information, like the status code. There's RESTful interceptors. So there's a MIME interceptor that handles content negotiation. So that ends up being also kind of a nice feature. In HTTP, what you're supposed to do typically is set the accepts header on the request that says what I'm interested in receiving in terms of a content type. Then the server decides, okay, you wanted application JSON. I know how to create application JSON, so that's what I'll give you. But then the server sets the response content type as application JSON when it sends back the response. So this header, or this interceptor, also parses the response based off of the return content type. So many other libraries will just say, I'm just going to assume that I'm going to get back JSON. And if it gives back JSON, it works. If you get back something else, many servers, if you have a 500 error, will give you back HTML by default. It'll still try and parse that as JSON, and you get an even bigger error. Also, in terms of authentication, saw the basic auth interceptor. There's also an OAuth interceptor. In terms of errors, we have basically the ability to trigger errors based off the response code, the ability to retry failed requests, as well as to just time out and stop. Then finally, some of the fallbacks, support for JSON-P for JSON-P-based services. Obviously, that one's browser only. And within IE, have support for cross-domain request, as well as trying to use the ActiveX XHR support for older versions of IE. So basically, you just add those interceptors and it just does it correct. So interceptors are also really easy to create your own and configure your own. So fundamentally, it's just a function that you give it a few other functions. So there's a few different phases of the request. So most of the time, you're going to deal with either the request or the response phase of the interceptor. So that means is when a request is going in, that function will be called, and then you can choose to return either just a modified request, or you can actually replace it with something entirely else. And at any of these phases, you can always return a promise for a future value if you need to go off and do some other asynchronous work. Within the request and response interceptors, or phases of the interceptor, you also get access to a configuration object. So for that basic auth interceptor, we were passing in a username and password configuration. So those become available in these callbacks, and you can parse them out and use those as values. Success and error is really just specializations of response. So whether or not the promise of the parent client was in a successful state or whether it was in an error state. So what does an interceptor actually look like in real life? They're very, very simple. The way it's set up is that you want to do, just like any other type of programming in a function, you want it to do one thing and you want it to do it well. So for a basic auth interceptor, really all we're doing is getting access to the request headers object, trying to figure out the username and password that we want to use. It'll look on the request object first, otherwise it falls back to the config. And then finally, assuming that a username is provided, it'll actually set the authorization header, basically encoding base64, the username and password together, and then finally returns that response back through, and the request continues on. So within these interceptors, because we have interceptors that have small chunks of behavior, we really want to be able to apply them together in aggregate. So the notion of chaining interceptors together becomes really important. You can basically create a pipeline of behavior that gets applied to the request and response as it flows through that interceptor chain. So what does that actually look like? So essentially, it's just, you get a client, and there's a method on that client called chain, which you can give the interceptor implementation as well as configuration for the interceptor if it has any. So in this case, we're taking that same basic auth interceptor, and then we're chaining it and applying the error code interceptor, which basically says, in this case, if there's a 500 level or greater response code, then take that value and basically treat it as an error instead of as a successful response. And then after that, we basically chain in the MIME interceptor, which is what does the content negotiation. And then finally, after that, we chain in the HADOS interceptor, which is what does the hypermedia API support. So these things together, you can figure out exactly what you actually care about in terms of the resource that you're trying to access. And you can then figure out what features you need to actually support, and you can figure out how they apply together. So another thing that's really common is to take the retry client if you're waiting for some resource to become available on the server, say like JSConf registration. Basically, you can just keep checking to see if something's available using some sort of interceptor. You can set it into a successful or error state. If it failed, you can retry again. And then finally, you can set a timeout kind of after it below that to say the whole thing, if it takes longer than 10 minutes, just give up. So realistically, in practice, the other big benefit is that because we have this configuration that's configured once and then shared within the application, it's really easy to make modifications for things. So if we take that previous interceptor, and let's say my boss comes to me and says, I heard about OAuth. I really kind of want you to try and look at actually utilizing OAuth in your application. That's something where most HTTP clients are just going to fall over flat. If they don't support it out of the box, you're kind of screwed. You have to go find some other client to actually understand. Excuse me. You have to go find some other client that actually understands OAuth, and then figure out whether that understands how to actually interact with everything else that you actually cared about making a request. But with rest.js, it's actually pretty simple. Basically, all we have to do is pop off that basic auth interceptor and apply in the OAuth interceptor. And that OAuth interceptor actually has a little bit more config because the auth is a little bit more complex. But fundamentally, the other interceptors in the chain don't really care what was before them. They just get the request and the response. And the clients that are actually making the request, trying to get back data, also don't really need to care that it was OAuth under the hood. And the other thing that's really useful here, particularly with OAuth, because you have to go off to another server to get an auth token, have that come back asynchronously, and then be able to actually make requests using that token. Making sure that you're using the same token for every single request becomes really useful. So having one interceptor near the root of your chain that the rest of your application can use and share becomes really valuable, because then the rest of your application can benefit from that token that got captured and cached. So kind of switching up a little bit, HTTP is just one thing that we have to use as clients. HTTP is really good for resources. It's not really good for events and event-based data transmission back between servers. If there was an event and we actually were running server-side, maybe we would use a webhook to be notified of that something happened. On the client, we don't have that option. There's no way for the server to establish a connection back to the client. So typically what people do instead is obviously they use WebSockets. WebSocket supports full bidirectional communication, client, server to client, client to server. But the problem with WebSocket libraries, at least the ones that exist today, is that they abstract sending and receiving of messages from client to server, but they really don't help you deal with messaging once you receive the message off of that socket. This is something that the server-side world has been dealing with for a long time. And there's a book called Enterprise Integration Patterns. This is basically the gang of four for messaging. And it really provides a bunch of simple patterns to really support messaging-oriented programming. And don't let the word enterprise scare you. I mean, it came out of enterprise computing, but these patterns are really simple. And if you're using AMQP or 0MQ or ActiveMQ today, that's kind of really what those concepts are built around. So another library out there is called msgs.js. It's also part of Cujo. And it's really an implementation of the enterprise integration patterns to really give you the core primitives of messaging. So beyond that, there's also adapters to other types of messaging systems once you want to leave your local world and move over the network to something else. So WebSockets happens to be one of those adapters. But let's kind of look at just a brief hello world of what it looks like in a messaging environment. So the first thing we have to do is require messages, and then we basically get a new bus for that message. So that's not something that's strictly required. The messages object is itself a bus, but when you chain a new bus off of it, you can get a local scope so all of your names are isolated and they don't collide with anything else. So on a bus, we're going to define two channels. So in this case, we have a channel called lowercase and a channel called uppercase. So a channel is just a place where messages are sent to, and other handlers can subscribe to that channel. Then we basically have a transformer. So that transformer is basically has a function that gets a message and then does something to that message and returns it. So in this case, basically getting a string, and we're calling to uppercase on it. And then in that transformer basically has a couple configuration parameters called input and output. These are the channels that we want to subscribe to. So input is the channel that we want to subscribe to, and then output is the channel that we want to send to once we've done our work with that message. And then we have an outbound adapter, which is basically just a way of getting messages out of the message bus back into regular code. So in this case, we're basically just calling console.log and subscribing it to the uppercase channel. And then finally, we're going to call bus.send. So send a new message to the lowercase channel, say hello world. Then ultimately what happens is it prints out hello world capitalized. And that's probably a ton of work for a hello world. And yes, it is. For very simple use cases, these patterns are probably overkill, but they really become powerful once you can actually have the need for decoupling your application, your systems this way. And we'll show an example of how that power really pays off in a bit. So there's several other primitives. I talked about a few of them. Channel. There's several different types of channels. The channel that we use by default is basically a point-to-point channel. So if you have multiple subscribers of that channel, for each message that goes in, that message goes out to one of those subscribers. Also have pub sub channels. Message comes in, everyone who subscribed gets a message. Exchange channels, which basically allow you to do topic-based routing, either based off of just some dynamic key or some pattern if you want to subscribe to, similar to how AMQP has topic exchanges, routing keys. Also have the notion of a queue channel if you don't want to have to deal with messages right away and you want to buffer them up and then pull them off as needed. So within the channels, you can subscribe, unsubscribe. There's also the notion of tapping a channel if you want to be notified every single time a message comes in. It's really useful for logging and other types of auditing. And then beyond channels, there's a notion of handlers. And handlers are things that actually do things with messages. So we saw a transformer. There's also filtering, routing, splitting, aggregating. Basically everything you kind of want to do with a message, basically that's a handler. Then finally, we have inbound, outbound adapters, as well as inbound and outbound gateways. Inbound is coming into the message bus, outbound is going out of the message bus. Adapters are typically unidirectional, just once fire and forget. Gateways typically are more request-reply oriented. So basically, it establishes a promise for a response. So let's kind of look at what this actually ends up looking like. So had a use case where it basically had a server where for every message that came into it, we wanted to send it out to every single client that was connected. So in this case, we have messages again, as well as a WebSocket server library. Realistically, we were using sock.js in this case as the server, but it could be just about anything. So we're establishing 2 pub/sub channels this time for messages coming from the client, and then messages that we want to send back down to the client. And then we have basically on the WebSocket server, for every connection, we want to take that connection, and we have a node stream gateway. So basically, this is a set of messaging adapters that, for the node stream API, can basically take every message that's coming in and put it to the output channel, and every message that's going out and put it to the input channel. So basically, what we're seeing here is on that bus, we're establishing the gateway for that connection. All the messages that are coming in get sent to the from channel client, because this is on the server. Everything going out goes like the other way. And then finally, what we're doing is we're forwarding the from client channel to the to client channel. So basically, everything that comes from a client goes directly back to a client. And because it's pub/sub, every client that's subscribed gets every message that was received. So, but there's also a fatal flaw in here, if anybody sees it. And it's that, we're running within a single process in a single instance. And we're only going to be getting the connections and subscribing them to the bus if they happen to be on the same local node. So typically what you want to do is have some other messaging gateway on your backend server. So in this case, we're going to introduce Redis for a very basic pub/sub. So requiring the Redis client. And one of the other adapters that we have set up is for a Redis gateway. So everything else is the same in terms of how we're interacting with the WebSocket and the channels. But instead of just forwarding from client to client again, we're actually going to take those messages and pass them through Redis for a very basic pub/sub. So messages come from the client on the WebSocket and up to the server. From the server, it gets sent to Redis. Then each of those server nodes is then configured to connect to Redis and receive messages back off of that bus. And then those messages get sent back to every single client. Then on the client side, again, we're going to use sock.js. And again, this code should look very familiar, and it's the exact same API, it's the exact same programming model, whether you're client or server. But in this case, we have a WebSocket gateway set up, and that's just a set of adapters that understand the W3C WebSocket API. So in this case, it expects to be given a WebSocket connection. So I'm using sock.js so we can get HTTP fallbacks and other things, in addition to just raw native WebSockets. And again, the input and output channels are set up so messages come to and from the server, and we can interact with them. So still have a couple minutes. If you actually want to see this running, you can go to JSConf.cloudfoundry.com, and I actually have that code running. What you'll see is there's a little circle that'll pop up for every user, and as you move your mouse around, the circle will follow you. And basically what it's doing is it's capturing the raw mouse move events on the browser, sending them up to the server, distributing them across Redis to each of the instances on the server, and sending them back down. So this application is actually running with 3 instances up on Cloud Foundry. And it's the Circles app, sample app within Kuja.js, if you actually want to go grab the source for it. And with that, I just want to say thanks. If you have any questions, I guess I have a minute. All right, so if anyone wants to talk further, just feel free to grab me. I'll be here for the rest of the conference. Thanks.